Hello and welcome. In this video, I'm going to show you how to model fluid flow and mass transfer in ANSYS Fluent. The objective of this study is to investigate the velocity and mass transfer distribution within the system. Our inlet is Ethane with an inlet velocity of 0.1 meter per second and a fraction of 1 since it is filled. The resulting product from the reaction are hydrogen and ethylene. Alright, let's jump into ANSYS Fluent and get started. Select Fluent. Right-click on Geometry and select New Design Material. Select XY plane, sketching and select a rectangle. OK. Here we create our rectangle. Click on Dimensions and select Design and Design. OK. The H1 is 10 and V2 is 2. OK. And now click on Generate and now click on Concept, Surface from Sketches. And here we select sketch 1 and click on Apply and now click on Generate. Right click on Mesh and now click on Edit. Click on Mesh and click on Generate. Okay, as you can see the number of elements is low, so right click on Mesh, click on Insert and Method, and here we select our domain and click on Apply, and here we use triangulars. Okay, and back to Mesh and we use 0.04 for the element size, and now click on Generate. Okay, it is our triangles mesh. As you can see, now right click on Mesh, click on Insert, and now we wanna create some boundary layers. Okay, so we select our domain, and for the boundaries we use this boundary, and also we hold Control and select this boundary. Okay, and now we select first layer thicknesses, and its value is 0.001. Okay, and maximum layers are 5. Okay, and now click on Generate. Okay, here you see the boundary layer. Okay, now we want to create the boundary condition, so select line and select this boundary, and we use here the inlet boundary condition, and for this boundary we rename it as outlet. Okay, inlet outlet. Back to Mesh and click on Update. Now right click on Stop and click on Edit. We use 5 solver processes and click on Start. In this example, we have a steady state simulation, so for the time we select steady, and now let's mount the models. For the fluid flow, we have a laminar flow, so we select laminar and click on OK. Okay, now let's mount the species. Species is for mass transfer, so we activate. Okay, and now click on Apply and click on OK. Now let's mount to materials. Open the fluid, right click on fluid and select New and click on Fluid Database, and here we need to define our component, so we select the material type or to change it to the fluid, and we need to select C2, H6, C2H4 and H2. We select ethylene, we select ethane, and finally we need to select hydrogen. Okay, and click on copy, click on close and close the window. Okay, back to species, click on edit here, so click on edit here and we select all components, hydrogen, C2H4, C2H6, and we remove O2, H2O, and finally N2. Okay, now click on OK and click on change and close, and here click on OK. Now let's mount cells on fluid and double click surface body. We active source there because we want to incorporate the reaction rate, so click source terms. For the H2, click on edit. Okay, and we use constant because in this example we consider a constant reaction rate because the hydrogen is a product, so we use positive value for the reaction rate of the hydrogen, so its value is 0.001. Okay. Also, for C2H4, we use one source and it is constant, and also its value is 0.001. The C2H4 is also a product, so we use positive value and its value is 0.001 for the reaction rate. Okay, now click on OK, click on apply and close the window. Okay, and now we want to define our boundary condition, so select inlet velocity. Its value is 0.01. Okay, for the thermal we use 1000 Kelvin for the temperature and click on species, and for mass fraction for the H2 and C2H4 we have a zero value because in the inlet we have only C2H6, so the value of the H2 and C2H4 are 0. Okay, now click on apply and close the window. For the outlet, double click on outlet. As you can see, for the outlet we use 0 gauge pressure. Okay, now click on initialization and initialize our system. And now let's move on calculation, and here we use 100 number of iterations and click on calculate. Okay, the run has been completed, and now we want to check our result. Right click on result and click on edit. Click on z-axis, select the contour 1, okay, select symmetry, and here we select velocity, click on apply. Okay, it is our velocity distribution. In the walls, the velocity is 0 because we have no slip-on condition, and also we have a different distribution in the inlet section or the outlet section because we have a different component. Okay, now we want to check mass fraction. For example, the H2 mass fraction, click on OK and click on apply. It is our H2 mass fraction. As you can see, for the inlet we have a 0 value, but as the length of the reactor increases and the mass fraction of the hydrogen increases because the hydrogen is product. And also we can check the mass fraction of the C2H6. Click on OK and click on apply. So as you can see, the mass fraction of the C2H6 decreases because it is reactant, and as the length of the reactor increases, the mass fraction decreases.